Unlock the power of Openshift and Google Cloud NetApp Volumes for your stateful containerized applications in Google Cloud. I'm Diane Patton, a technical marketing engineer at NetApp. In this video, we will demonstrate how easy it is to pair Openshift Dedicated with Google Cloud NetApp Volumes. But first, let's introduce both products. Red Hat Openshift Dedicated is a managed Red Hat Openshift offering available on Google Cloud. It provides an application platform to reduce operational complexity so you can focus on building and scaling applications. These showed benefits here make Openshift and Google Cloud a powerful platform for developing, deploying, and managing containerized applications with efficiency, scalability, and security that add more value to your business. NetApp Volumes is a Google service that provides high-performance storage solutions for Openshift stateful applications and many other workloads. It offers low latency access, high IOPS, and high throughput, ensuring that your applications can handle demanding workloads with ease. It also offers advanced data protection and disaster recovery features, and the volumes can scale and grow with your Openshift deployed applications needs. Pairing the scalability and flexibility of Openshift Dedicated with the unmatched reliability and performance of Google Cloud NetApp Volumes provides an exceptional experience for your customers. Next, let's move to the demo. We have an Openshift Dedicated cluster already set up with 3 worker nodes in Europe West 3, 1 in each zone. We will create a NetApp Volumes Flex storage pool with regional redundancy and set everything up to use that storage pool to create and access volumes for any stateful applications deployed with Openshift, and we will deploy a sample application. Finally, we will fail over the volume to the replica zone and show the connectivity to the applications remain. Now during this video, we will show the console, but of course everything can also be done via the API. So we are starting on the Openshift console, where we already have a dedicated cluster set up in Google Cloud. You can see we have 9 nodes in this cluster, with 1 worker node in each of the 3 zones in Europe West 3, and they're all ready. Next, we move to NetApp Volumes. Here we'll create the storage pool. All volumes created for the Openshift applications will reside in this pool. Give it a name. Select the location, which we will use the same as the Openshift cluster. We will use the Flex service level, but there are several service levels to choose from. More information can be found at the below URL. And we'll select regional availability. So we select Zone A as the primary zone and Zone B as the replica zone. So this means if we lose access to the volume in Zone A, we will still have access to our data in Zone B. So next we choose the capacity, and we'll connect it to the VPC with the Openshift cluster. And we had already peered it. We can turn off AD for this application and then hit Create. So after some time, the storage pool comes up, and we can see that there are no volumes in it as expected. Next, let's install Trident, the CSI provisioner. So going back to Openshift, we could install Trident Operator from Operator Hub, but alternatively, we can also use Helm. Now, if we don't currently have the Helm application, we can get it here by going to the command line tools and download it. In case you're not familiar, Helm is a package manager for Kubernetes, similar to Yum or DNF for RHEL. So going to the terminal, so you can see we're on the same cluster, we'll use Helm to install Trident. We will install it to an Openshift project called Trident and create that project or namespace at the same time. So back on the Red Hat console, we'll filter on the Trident project, and we can see those Trident pods are already up and running. We need to give Trident permissions and tell it where to create the volumes. So first, we'll install the secret that contains the permissions. The backend file tells Trident where to create the volumes, so let's take a look at that. This is where we can name the backend, we tell it the location, and we can even denote the storage pool that we want to use. But that's not required. So let's create that backend. And we can see it came up and is bound. Last but not least, we will need at least 1 storage class that uses Trident with that backend. This is a sample 1, and we also made it the default. One nice feature of Openshift is that it allows you to just enter YAML files directly into the console. So to show that, I'll just cut and paste this YAML file directly into the Red Hat console. And please note the storage classes are not namespaced. So going to the storage classes on the console, we can see it was added. So let's install an application that will use Trident to provision volumes. And we can once again use Helm to install WordPress, and we will create a project called Blog and install WordPress there. So after a moment, both pods are up and ready. The PVCs were created, and Trident created the corresponding persistent volumes that we can see here. Going back to NetApp volumes, we see the volumes have been created for those PVs. We will access that WordPress site now that we just created, and we are accessing data on that NetApp volume. So let's emulate a zone outage for the volume by switching the primary and replica sites. We can see here that the primary is zone A and the replica is zone B. So let's initiate that cross-zone move. During this move, there is a short outage, but it's within the NFS timeout limits, so no outage is noticed. So after that's complete, we can see the zones have indeed switched, and the volumes are still there as before. And the PVs are still shown and accessible by Openshift. By combining Openshift with Google Cloud NetApp volumes, you can achieve a robust and reliable storage infrastructure that enhances the performance, scalability, and data management capabilities of your stateful applications running with Openshift. Try it yourself. See more about Openshift dedicated and NetApp volumes at these URLs. Thank you for watching and have a great day.